In this section, we are going to see how to create the intersection layout. Before creating an intersection or modeling an intersection, we need to create the intersection layout first. So in this drawing, you can see I have a junction or an intersection connecting two roads here. So we call this the main road, and this is our secondary or side road. So you can see when you are creating a junction layout, or otherwise how the junction is behaving at a turning, you need to use turning simulation. We call them swept path analysis. In this case, I have used two vehicles. One is going from this side to turn this side, and the other one is coming from this side to turn into this secondary road. So this vehicle is SU30 single truck, but depending on your situation, you have to select your vehicle type. So for this layout creation, we will be using a simple layout, but there will be certain intersections that has very complex layouts, but you have to model them after creating the layout using this swept path analysis. So now when we are creating the layout, we need to make sure our edge of this road is away from this vehicle path here and here. So to get that, we are going to do some kind of circle here, so that it gives us our edge of curb line, we say, or edge of the turning. So to do that, I'll go to my home tab. From here I will use tan radius option. So I click this one. I have to select two locations where it gets tangent. So I'll select this edge of this road and edge of this main road. So our circle will be created tangent to these two roads. So for the radius, I'll give 15. So now I press. Now I have created the circle. You can see now this turning is okay with this circle. So what we have to do now is we have to trim off the unwanted parts. So I'll launch my trim command and I'll remove the unwanted parts. So now you don't need this part as well, because it will be turning like this. So I'll press escape. For the same manner, I will do the same to the other side. I'll go here, launch that command, and this is my first tangent, this is my second tangent, and my radius would be 15. I press enter. So this radius will be changed depending on your situation, so you have to select the correct type of radius. So I launch the trim command again and I trim the unwanted parts, then I press escape. So now you have two turning areas. So I am going to make this in the same color as this one. So I use match properties command, MA, and press enter. I select my source object as this one and make sure these are my destination places so that it matches with the source layer. Then I press escape. So now I have to put this into a new layout drawing. So I click this, I select these lane edges only the lane edges. You don't have to select the center lines, only you select the lane edges. Now my all edges are selected now. Then I right click and go to cut inside clipboard. So I'll remove all these things and go to a new drawing from here. Then I'll paste them onto the original coordinates. So if the original coordinates are grayed out here, you can use the same option in the paste here on this home tab. So once you click that one, it will be pasted onto the drawing. To get that one, double click your mouse wheel. It will zoom extend. Right, now this is done. This is our layout. So we need this as an external reference while we are doing the work. So you have to save this drawing as intersection layout somewhere in a convenient location. So that is how to create the layout for our junction. This is a simple layout so that you can easily create the junctions, but in real terms you may encounter with very complex intersections, but the modeling and creation of layouts are very much similar to this one. In this section, we are going to create the edge alignment for main road and the secondary road. These edge alignments are used to create the junction and also create the curb returns. Right. So to do that, I am going to follow few methods. I will tell you three methods, so you can use either of these methods. So we are assuming that our two roads have 4-meter lane widths for both roads. So first one, to create the edge alignment, I am going to follow offset alignment method. So to do that, I go to Home tab and I go to Alignment, then go to Create Offset Alignment, and I'll select this alignment, and this is my offset alignment I will create throughout this road. So my width would be 4 meter either side. So in this case I am removing this option. So if this is inside it, if it is turned on inside your Civil 3D, please turn it off because we are going to set up the profiles later. So I go to General tab and we are not going to change anything, and I am going to click OK now. So it will create us the two offset alignments representing the edge of the road. So in the similar manner, I will create the offset alignment for these two as well. Before going to the secondary road edge alignments, I need to make sure where the secondary road stops at the edge, because we have this curb return turning from this two sides. So what I do is I will be xrefing my layout to find out that location. So I'll type xref in my command line and I'll press enter, then go to attach drawing, and here you have this intersection layout which we created earlier, that is our xref. So I'll click OK and make sure these settings are like this and click OK. So you have my layout like this. So we have to stop our main road edge alignment somewhere here in both sides. So I click close this one. So this time, to get the offset profile, I will follow a different method. So I click this one and go to offset alignment, and this is 4 and this is 4. This time this is starting from the bottom side or the southern side and going up. So my start is okay, but for the end I will stop somewhere here. So to get the object snap, I will go to end object snap is on. I turn on my object snaps and I will get this end, and both these ends are same because of the symmetrical behavior. So I'll click this point. Now it will be creating my offset alignment up to this point, because after that we will have this curve or the curb return alignment. So I click OK. Now you can see both sides now completed. So you can see here this side and this side are completed, and for the secondary road also both sides now completed. So if you want to extend this offset alignment, you can use this script to extend it. So I'm not going to extend it. I'll press escape. So that is how to create the edge alignment using the offset alignment method. So another way to create these edge alignments is to create the edge alignment using normal alignment tools. So what we can do is you can create a polyline along this edge and convert it to a alignment. So this time what I am going to do is I am not going to create a polyline here. Instead I am extracting this polyline from the xref. So to do that we type nc to get the n copy or nested copy option. Also type nc, then I click all these lines at once so that I get all these alignments, all these lines into the drawing. Then I press enter again, and press enter again 3 times. All these alignments will be back in this, all these polylines will be back coming into the drawing. So what I do now is I am going to create alignment from object. So I select this object and make it to a alignment, press enter. Now it is asking the direction, it is going from this way to this way. I accept that direction and I am going to convert it to alignment. So I am not going to add any curves here. I will erase the existing entities after creation of the alignment. So my alignment name is main road LHS and I'll click OK. So you will see your main road LHS is created. So you can convert it into a offset style and click OK like earlier. Earlier when we are creating the alignment, edge alignments using offset alignment, we didn't use the name for the offset alignment because we automatically got the name from the offset alignment. But this time you have to get the alignment name, you have to type the alignment name by yourself. So now I am going to do the same for the right side. So I go here, create object, alignment from object. I'll click somewhere here and press enter. Then my direction would be this one. I accept that direction and this time it is main road RHS, and this time I will change the style up front and click this, uncheck this option and check this option to delete the entity after creation of the alignment. I click OK. Now I have that alignment. So if you click here, you can see I have this main road RHS. So in the similar manner, you can create edge alignments for the secondary road as well. In that case also you have to give the respective names for this edge alignments. So that is how to create the edge alignments for the main road and secondary road of the intersection. After creating the edge alignment for main road and secondary road, next what we are going to do is to create the curb return alignments. So in other words, these turning alignments. So to do that, we have to create new alignments in this turn and this turn. So the trick here is use one alignment direction when you are creating the curb return. So as a trick we can do, we are going to create the alignment in the direction where the vehicle turns. So I am going to create this intersection from this side to this side. So I go to Home tab, Alignment Creation Tools, and my alignment name would be I would say this is southwest corner. This is south, this is west, so southwest corner. I say southwest curb return. Then my style would be this one, same as earlier. This one, offsets, and I will use this no labels option, and I click OK. So when you are creating the alignment, make sure you are going to overlap this alignment with this offset alignment. So you have to start somewhere here, like about 10 meters before the curve, and you have to end the alignment about 10 meters away from the curve. So first we are going to have a line here. So I'll use this option, fix line 2 points. So I start somewhere here and go to here. Now my line is created. Then I'll start another line from here to here. So I stop this line at this end, and I go to here and start another line at this end point, end of this curve, using the object snaps, and I come to this side and press enter. So in between I have to add a curve. So I'll click here, then go to free curve fillet between two entities through point. I click here. For the first entity I will click this one. So make sure you are selecting the correct alignment, because we have two alignments here. So you can see when I am highlighting these two, you can see the correct one highlighted. So the top one is not the correct one, bottom one is the correct one. So I click this one, and for the second entity I have to select the other alignment part. So you have to select the correct one from this list. So I click here, and for my true point I will click somewhere on this curve. So using the nearest snap, this nearest snap, or maybe the midpoint snap, you can use either one. So I click here. Now my alignment is created. So my curve return is now created, you can see like that. So in the same manner you can create another alignment from this side to this side for the other curve return. So I'll close this one and go to alignment creation tools. This time it should be southeast curve return, and I'll click OK. So I'll start somewhere from here and come to here and press enter, and then I do another one. This time I'm using this option. This option or this option, maybe both are similar. So you have to use any of the alignment creation tools in this case. So I'll press enter again. For the curve I will use this option here. Right, so since this is symmetrical, make sure all these are in line with each other. So you can see this is longer, this is shorter. So what you can do is you can simply draw a draft line from here to here, and with a perpendicular snap I will mark the matching point here, and I will reduce the length of this alignment up to here. Then I delete this one. In the same manner you can do, you don't have to do anything on the right side, so, and this side also, because you don't have a crossing here, right? So if you like, you can make this length equal to this, but it depends on your choice. So this is how to create the curve return alignment for the intersection. In this section we are going to match the secondary road profile with the main road. So this is our intersection area or junction area. We know that junction is belong to this area, but the secondary road is going into the main road. So we have to make sure that the main road section matches with the secondary road. In other words, secondary road should be in line with the main road in this section. So we are going to do that in such a way that by creating a temporary corridor. So I press escape here. Now I will change these curve return alignment styles so that I'll get more control when I create the corridor. So this time I will add this as intersection basis for the moment. Now it is giving a white color. So I am going to change this as well. Instead of changing the style, I am going to type MA on my command line and press enter to use match properties. I'll select this alignment and go to here and mesh that one, then it will match the styles. Right, so now I am going to create the temporary corridor. Before that, I am going to create the assembly. So to create the assembly, I go to home tab, assembly, create assembly. So my assembly name is temporary corridor main road, and I'll click OK here. I will click here to add the assembly, and I am going to add the sub assembly for this one, both left side and right side. So I click here and go to lanes tab. From here, go to lanes tab, lane super elevation AOR, and I click here and I close it now and press escape. Now I close the tool palette also. I go to the sub assembly and go to sub assembly properties. So this is temporary lane RHS, and I click parameters now. So my lane width would be 4 meters as in our assembly, and my default slope I'll change it to as 2.5. For the pavement depths, I'll make them all 0 because this is a temporary assembly. So we are not going to use super elevation at this moment, so I am setting it to none. We will see how to use super elevation in a later section. And slope direction away from crown, potential pivot no. Inside point code, we don't need this at the moment. We'll set both of them to none, outside point code, and I click OK here. So now this is our lane assembly. So we are going to add another assembly to this one so that we create a more accurate temporary corridor. So I'll click this one here, go to copy from here and click here. Now it is copied, and then I go to this copied or the outside assembly, go to sub assembly properties. This time this information tab, change the name as extension. This is extension of the lane. So this width I make it 0.5, and all the other parameters will be as it is. If we have super elevation, we will have some other work to do, but we will see it later. So I click OK here. Right, now I mirror all these to the left side, because at this moment we don't need this for the main road temporary corridor, but later we will be creating a secondary road temporary corridor. For that one we need both sides. So since we are using this for the other corridor as well, we are creating whole section. So I click here to select these two assemblies, mirror, and I click somewhere below here, it will mirror to the other side. So I go to this assembly, sub assembly properties, this is LHS, and click OK. And here for the next one should be LHS. That's all. Right, now we are going to create the temporary corridor. Before that, we need to make sure we have some settings set in our drawing. So I will explain what this setting later. So I go to settings tab here, then I select this, the drawing title, right click, edit drawing settings, then go to object layers, then go to corridor, and here set this to suffix and click have a dash, then asterisk mark, right? Then asterisk mark. So if you read this part, you will see what do you mean by this, right? You will see what do you mean by this, right? We'll have a dash, then asterisk mark. I'll click OK. All right. Now I am going to the prospector tab. Then I go to home tab, corridor here. So this is Civil 3D 2025 version interface. So if you are using Civil 3D 2024 updated versions, you will see similar to this one. But if you are using Civil 3D older versions like 2023 or 22, 21 like that, so you will see some kind of a different interface than this for the corridor, but you can understand where the locations are. You can fill out what I am doing here in your one as well. So my corridor name would be temp corridor. I'll say main road, right? So my assembly is main road, alignment is main road, profile should be main road profile, assembly should be temporary corridor main road. Even though this is main road, we will be using this to the secondary road as well later. So I'll click OK and make sure you are setting baseline parameters and region parameters here. You don't need to change anything from here. Click OK. Now we are going to create our temporary corridor. So in this case, we will be creating the temporary corridor within the junction area only, or within the intersection area only. So for the start station, we will be going to the start of the intersection area, which will be this white line ending location, this curb return line ending location. It should be somewhere here, and for the end it should be somewhere here. So you make sure you have turned on your object snaps, endpoint object snap from here. I am getting the endpoint snap. Right, now we have done our part. Then you have to set your frequency. Make sure you have set your frequency at a very lower level, like 1 meter corridor. That will give you a more accurate surface for the temporary corridor, which will be important when we are creating the curb return alignments, right? So I'll click OK here, right? Then I'll go to OK again and rebuild the corridor. So you will see you have this temporary corridor here, right? Now we are going to create this temporary corridor surface, or the surface for this temporary corridor. To do that, I select this, go to corridor properties from here, then parameters, surfaces, click here to create a surface. So temporary corridor main road, top would be our name, surface name. I'll click here to add the top codes to our corridor surface. I click to add them as break lines and top links as overhang correction. Finally, I go to boundaries tab, right click and set a corridor extent as our boundary, and click OK and rebuild the corridor. Now you will have a boundary at this edge, or surface at this edge. So if you click here, you will see our temporary corridor main road top surface is created. Now what we do is we will add this corridor surface into this secondary road alignment, so that it shows the main road profile or main road surface along this secondary road. So we can mesh the secondary road to the main road. So to do that, we click the secondary road, go to surface profile, then we are going to add the main road top, temporary corridor main road top to our secondary road, then click OK, right? So I close here. Now if you go to here, you will see this is your temporary corridor. So this is how your main road look like, but at the moment your secondary road is like this. So we have to make sure we are modifying this profile along this line. So I'll move this profile up until this point, but this is matching at this point, but it should match along this profile. So to do that, what I'm going to do is I'll select this one and I'll go to edit geometry. Then I will delete this curve at the moment. Before that, we will check its parameters. Curve length is 50. So I'll click here and press escape. I deleted the curve from here and press escape. Now I move this grip from this center grip until the end of this main road corridor surface. Then from this side grip, I will drag it. It will maintain in the right side slope once I drag it. So I'll drag somewhere here and I will set this as 50 meters, right? So if you need, you can add another curve here or add any modifications, but while you are doing any modifications to this one, make sure this side do not change much. That is the important thing. When you are changing this side, make sure your left side do not change much. So you have to make sure that one. Right now our main road and secondary road match with each other at the connecting location. In the next section, we will see how to create the curb return corridors for these curb return alignments. In this section, we are going to create the curb return profiles. Before that, we need to create a temporary corridor for this secondary road also. So I'm going to my home tab, go to corridor. So this time this should be my secondary road and alignment should be secondary road, profile should be secondary road profile, assembly should be the same assembly we use for the main road temporary corridor. So I'll click OK here to set baseline parameters, and this one also I'll be creating from this alignment start to somewhere here. So you don't need to go up to this point, we will end somewhere here, and as earlier we will be having closer frequencies to make more accurate corridor. So I click OK and click OK and rebuild the corridor. So you can see now it is also created. Now I will create the corridor surface for this one. So I click OK here, click the corridor here, go to corridor properties from here, and on the surfaces tab I click here to create corridor surface. This should be temporary corridor top, and add top code as our surface basis and top links as our overhang correction, and add them as break lines. Go to boundaries tab, right click and add corridor extent as our outer boundary, and click OK and rebuild the corridor. So I press escape. Now both temporary corridors are created. Now we are going to create the curb return profiles. So this is one curb return as alignment, and this is the other curb return alignment. So we know that from this point towards this way, our curb return profile should match the main road because it is along the main road. So from here to here it should match the secondary road. So that is why we created two temporary corridors to get the elevations for this curb return alignment. So I'll click this one, our southwest curve return or SW curve return. Then I go to surface profile. So I will add temporary corridor main road and temporary corridor secondary road to this alignment. So make sure this is on the southwest curve return, and go to draw in profile view to create a profile view, because we haven't created the profile view yet for this alignment. Go to next. We are not going to change anything at this point. Click next again and click profile view. Then I will click it somewhere here. So you can see I press escape. This is your secondary road. So if I click here, you will see secondary road because the start side, and this is my main road. So your secondary road should match with the secondary road, and main road should match with the curb return at the start and at the end. And for the middle area, you can modify it. First, we need to mark from which point we can modify the profile. So if I click here, up to this point, this is along the main road. So at this point, at this point onwards, it should match the main road, and this point towards this way, it has its own profile. That means the curb return has its own profile. So here at this point also the scenario is same. So what I do is I label this point and this point to check where it is. So I go to add labels from here. I add station offset. So I click this endpoint here. I go to endpoint and I find this endpoint. So I shift right click and go to endpoint here to get that one. So I click this endpoint and our offset is 0. I'll type 0 offset. So it gives your label here. And similarly, I come to here and do the same, 0 offset, and press escape. So then it has some kind of a bigger label here. From this point, you can grab this label out so that you know what it is. So at 4933 and 2577, you have this match points, and in between you don't have to match anywhere. It can have its own profile. So what I do is 25.77 and 49.33, we will create these points on the profile. I click here, go to add view labels, station elevation. So my station is 25.77 and my elevation should be this one, and 25.77 elevation should be this one at this end, and I click here. Then my other one 49.33, and this is somewhere here, right? So when you are creating this profile, from up to this point, it has to match this profile. Then after that, it can has its own profile. Then after this point, it has to match the other profile. So now we are going to create this profile. So I click here, go to profile creation tools from here. So our name would be SW curve return FG for finish profile. So we don't need to have labels actually. So I click OK here. So it will give you the toolbar. So I'll go here, draw tangents. So I'll start from here and come up to here, and then go up to this point. Then I go to this point at the end. So you don't have to worry if it is not matching at this point, this area, because we are only concerning about this area beyond. So what I do is I will drag this somewhere here from the right side grip, and I will drag here this one from the left side grip. So if you like, you can have two curves here, otherwise you can keep them as it is. If these gradients are very smaller, you can keep them as it is, otherwise you can add two curves here. Let us say we are going to add a 10-meter curve here, 10-meter curve. So you add a 10-meter curve here and you add another 10-meter curve here, then press escape. So these things are normal profile modifications in Civil 3D. I'm not going to detail into that one. So make sure when the curve is created, that curve does not go into this location and on this side as well as on this side. So now our profile is completed for the curve return alignment on the southwest. So similarly, you can create the same curve return alignment to the southeast side as well. In the next video, we will see how to create the intersection corridor because we have now created most part of these things. In this section, we are going to understand and we are going to create the assemblies for our intersection. So in terms of assemblies, there are several assemblies we have to make. So if I come here, this is our intersection area. So we have to create an assembly for this area, and we have the main road area. In the main road area, we should have two assemblies at least, because if you consider here, up to this point, from this way up to this point, we have a full width assembly. After that one, in this region, we don't have a full width assembly because the right side part is inside the close to the intersection. So right side part should be trimmed on the main road and left side will be going as normal. After the intersection area, again the full width comes. If you consider the secondary road up to this point, that means up to the intersection point, up to the start of the intersection area, we have the full width. So we have to create several assemblies to get this done. Since my main road and secondary road lane widths are similar, I can create one full width assembly. But if you have different lane widths on main road and secondary road, you have to create different assemblies. So we will start creating assemblies. So I'll create the assembly somewhere here. So I'm going to assemblies here, click create assembly, and my assembly name I will type full width assembly here. So I don't need to type main road because we are creating one assembly for main road and secondary road both. So if you like, you can add a description. What is this full width assembly means? What are the lane widths? What are the thicknesses, like that. So I'll click OK here. Then it is asking me to select a location. I select a location close to my previous assembly. Now I am going to add several parts to this one. That means lanes, curb returns, and footwalks. So I go to Tool Palette on Home tab. Then I go to Lanes tab. From here I go to Lanes tab, Lane Super Elevation AOR. This time I will fill all these values here. So I'll click here. My lane width is 4 meters. My default slope is -2.5. My pave 1 depth, I'll set it to 50 millimeter. That means 0.05. Pave 2 also 50 millimeter. Base depth 200 millimeters. That means 0.2 meter. and sub base test I'll accept as 300 millimeters. I am not going to use super elevation. If you have super elevation, you can set it here. Potential pivot, no. And inside point code crown, outside point code edge of payment. Now all these sets are completed. So if we are going to add to the right side, so what we do is we go to close to the assembly. I'll click somewhere down here. Now it will attach my assembly to the right side. So without changing anything here, I'll click again at the bottom. So you will get the left side as well. That's a simple trick to get these things done very quickly. I'll press escape now. Now I am going to add a curb return here. So I add this curb return from the curbs tab, and I'll get curb and gutter general, and I will attach it to this top part. I am not going to change any parameters here. I'll attach to the top part, and again I will attach to the top part of the left as well. Then I press escape. Then I go to in the same tab I am going to urban sidewalk to add a sidewalk. So I'll click here to add that sidewalk, and click here again to add that sidewalk as well. Right, so that is completed. So then we are going to add daylight as cut and fill slopes. So I go to this daylight tab, and I'll select daylight bench. So I'm not going to change any parameters, but if you like, you can change the parameters as you wish. So I'll click here and click here. So now our assembly is very much completed. I'll press escape and close this tool palette as well. Now I am going to change the names of these sub assemblies to get a very clear understanding what is happening in each assembly. So I'll click here. I go to assembly. So my full width assembly. Then I go to construction tab. So in this way you can update them straight away everything. So for the lane, this is right side. I'll type lane R. So this one curb and gutter R, urban sidewalk R, for right side daylight bench R. So in the similar manner I'll change the left side, lane L, curb and gutter L, urban sidewalk L, and daylight bench L. You have to click here once. It will show you the renaming option, so you can rename them easily. Now everything is done. I click OK. So this is my full width assembly for main road and side road. So if you have different type of main road and side road, that means if let us say in main road you only have footwalk, but in the side road you don't have footwalk, so in that case you have to have different kind of assemblies for this. So if in that case you have to create different assemblies. That's something you have to remember. Now we have this full width assembly. Next I am going to create this mid block assembly, or we call the mid block, in the mid area of the junction. So in the mid block assembly we don't have this right side curb and gutter and footwalk area because it is inside the intersection. So what we do is we are getting a copy of this assembly. To do that I am going to the home tab, copy here, then I am selecting this bottom part of the assembly, then right click, then it is asking for a base point. I am selecting this lower point as my base point, then I drag it somewhere here, and I am getting a copy of that assembly. Then I'll press escape. So in that assembly, what is the difference? The difference is we don't have this footwork and everything on the right side. So what we do is we'll select this parts and press delete. Then our mid-block assembly is completed, but I'll go to rename this assembly. I'll click here, go to assembly properties. So this time it is mid-block assembly. Block assembly and click OK. Then we have to create the curb return assembly this way or this way. So earlier I said we are creating the curb return in the same direction. Like if you get this curb return into this direction, that means turning anti-clockwise, this should also be created as anti-clockwise. So in that way you can have one assembly, because if this going in this direction, so the assembly should be on the right side, the lane assembly. So if you go, if one is going this way, in the same manner it will have the assembly on the right side. Otherwise, if this is going on this way, you have to have another assembly on the left side. So that means you have to have two assemblies, but in this manner you will only have one assembly. Right, so now I am going to get a copy of this assembly to create that one. So I go to here, copy here, base point here, and come here and click that one. So in that assembly you have to spot the difference here. So let us, we know that this is going from this way to this way. So your right side there would be a lane, so which connects to the main road, and this secondary road and main road area. On the left side we don't have any lane part, but we have the curb and gutter and the footwalk. But on the right side we have only the lane, no curb and gutter or footwalks. So you know what, now my right side is okay because it is already having a lane, but on the left side we have a lane, we don't want that lane. So what we do is we will click here and delete this lane. So now our curb and gutter comes to the center line or base point and connect with this lane. Now this is similar to the assembly what we want. So what we do is now click this one and go to assembly properties, and I will change this assembly name curb and curb return assembly. Let us say curb return assembly. So I'll click OK. So now we have all the assemblies we needed for the corridor. So it is now perfect. Next we are going to create the intersection corridor. In this section we are going to create the intersection corridor. We have already finished creating the intersection assemblies. Now first we have to delete, or we have to hide these. We can't delete these temporary assemblies, but we have to hide these temporary assemblies. So the best way to hide these temporary assemblies is to freeze these assembly layers. So if you can remember, in an earlier video I told you to do some modifications in the settings tab, and in the drawing settings I asked you to modify this corridor as this. So that is because in each time we create a corridor, it will give the corridor a new name, which currently followed by the name of the object, otherwise the name of the corridor. So I click cancel here. So if I click this temporary corridor, this is temporary corridor main road. So if you go to home tab and click this layer manager, you can see this layer is temporary corridor main road. So in the same manner we have a temporary corridor second road as well. That means we can hide these layers. Hide means freeze these layers. We can't hide these layers with this turning off this bulb or turning off the layer. That will remove the layer from the drawing for some time, so it will not interact with the drawing. Instead, what you have to do is you have to freeze this layer. So when I click here, you can see this layer is no more. In the same manner, you can click this other one and go to the other one and freeze that layer also. So when you freeze those layers, the drawing, you can see the settings will be still there. Otherwise, these surface profiles would be get deleted if you delete or hide those layers or delete those corridors. But we need them if you do any modifications in these corridors, like main road or secondary road. We need them to get update the curb return profile. So we don't delete them, we will instead freeze them. Now we have two profiles here, so we need to hide them as well. So we click here, actually not profiles, surfaces. We'll go to no display option from here and from here as well. So now our drawing is very much cleaned up in this area. Also, we can delete these station labels because we don't need them at the moment. We created them to identify the matching locations on the profile. Since we have marked them on the profile, we don't need them at the moment, so we can delete them after selecting. So now we are going to create the main road corridor. So I go to corridor from here. Then my corridor name would be intersection corridor. So if you have so many intersections, you can give different names for your intersection corridors. For the alignment, I'll select the main road. For the profile, it would be main road profile. And assembly, I would select this full width assembly. And for the target surface, I am selecting EG as my target surface. So if you're having different version there, this is 2025, so like 2022 or 20, you will have a different interface than this, but I think you can find the places in your interface as well. You have to complete these parts. So I'll click OK. Now we have to set our intersection corridor locations, actually start station, end station, and frequency. So I'll click here to set my start set. Right, so this would be our start of our intersection, and end would be this one. So you can see now it is setting from here to here as full width assembly, but we know from here to here it is not the full width, it should be mid block. So in that case, I'll right click and go to split region from here. Then I'll select this point to split, and again this point as my split point. So you can see when you are splitting, the chain edges are coming at this place. So when you are splitting, make sure you have turned on object snaps like endpoint snap or maybe the intersection snap. So I'll right click. Now my assembly is now split. Actually my corridor is now split into 3 parts. So for the middle part, I have to set my mid block assembly. So in this time, if you have any targets, you can set at this place, but we are not going to use targets like width target or elevation target at this point, so I'm not going to do that at this moment. But if you have to set them. So I mean for the main road corridor. So I'll go to now for the secondary road, because now main road is completed. Now we are going to add the secondary road to this corridor. So we go to here, add baseline. For the baseline, this should be secondary road, and I'll click OK. So we are not going to have a feature line, only the alignment and profile. And my profile would be secondary road profile. Click OK. So then I'll right click here, then go to add region. For this one also we are going to use the full width assembly. Then I click OK. So you have the region added. So it would be coming from maybe from 0 to somewhere here. Somewhere here. Not 0 actually. It should start from here where the curve return alignment starts. So this is where you have the secondary road assembly parts for this corridor. So at this moment I'll set all these frequencies as 1 meter so that we get a more accurate corridor. So I'm not going to change the other parts. I click OK. So we need to add curve returns for this corridor, but before that we are going to create the assembly and see how it works at this point. So I'll click OK. So before clicking OK, make sure you are going to targets and see whether your all surface targets are set. You can see here your surface target is not set. Here also surface target is not set. That is, they are related to the secondary road assembly we have included. So we have to make sure we have set them here for all things. So if you are using older versions of Civil 3D, this interface is little bit different from the newer interfaces. So I think you may understand where the locations you will see to you need to see to set these assemblies and targets, right? So I'll click OK and I click OK again and rebuild the corridor. So you can see we don't get any errors. Now our corridor is nicely created at this point. Then what we have to do is we have to create these curve returns. So when you are going to create these curve return corridors, the logic is like this: from here to here, like from here to until this point, we will have the corridor. Like the assembly is coming from here, then it is targeting the elevations on the secondary road. After that point, it will going like this, and it will target the elevations and also the width. In this case also the width and elevation, in this also the width and elevation. So this is for the width, it should be this alignment, main road RHS alignment. So we know that we already have the elevations on this secondary road because we have this secondary road elevations, but we don't know whether we have elevations on this main road RHS, right? Main road RHS, because we need to target the elevations of this as well. So we need to make sure we have the correct elevations on this main road RHS alignment. So to make sure that one, we go to surface profile. So currently we don't have any elevations assigned to this second main road RHS alignment, but if you assign elevations, it should be the elevations from the corridor which we creating now. Otherwise we can get the same thing from this corridor, temporary corridor main road, because it follows the same elevations of the final corridor. So that's why we said we need it, because we cannot delete it or we cannot hide it. That's why we freeze it. So we will get the elevations from the temporary corridor to this alignment so that we can complete the targeting. So I'll click add here and click OK. We don't want to create the profile views to see how it looks like. We just add this and add it to the corridors later. So I'll click OK here. Now it gives the information notice and right click. Now I go to the corridor again, go to corridor properties. This time on the parameters tab, I am going to add a baseline. So this time I am going to add the southwest curve return first. So my profile would be southwest curve return FG, and I will going to add a region as by assembly. So the curve return assembly would be the assembly we are using. Then we have completed this region. So this region start point would be this corner, because this alignment is going from here to here. So region start point would be this corner, and region end point would be this corner. Right, so now it is completed. So now it is completed. So I will do the same for the so before I will add the same for the other side also. Southeast completed. So I'll add this profile and add a region like earlier, same assembly, and start point would be this corner, end point would be this corner. Make sure you are using the correct snapping options. So this time also we can set these to 1 meter to get more accurate corridor. So if you like, you can set all the regions at once without doing them multiple times. So you can set all the regions from here. So I'm not going to set any targets at the moment. I'll just click OK and see what is given here. Before that one, I have to make sure I set all targets here, because we don't have targets for the EG. So I'll make sure my targets are set and click OK and click OK again. So this is how it looks like at this point, but we have to make sure that this lane touches here and this part touches here. It should stop here and this part go up to here, and also it should target the elevations from this secondary road and elevations from this main road RHS profile. So now we want to set the targets for this region of the corridor so that it connects this part and this part. So I go to here, go to corridor properties. So in the SW carburetor, this one I right click and here I will right click and go to split region. Then I'll split the region from this point where these touches with each other, this line and this line, the connecting point, I will set it here. Now I right click. Now you can see it is now splitted. I'm going to the other one as well, and I will select the split point here as well and right click. So now I am going to set the targets. For clear identification, I will turn off some parts of these and explain them to you separate. So now I am going to set the target for this region only. So I'll click the corridor, go to edit targets, then I'll select this region, right click, enter. Now you have to set the width and elevation targets. So for the width target, it should target this, right side secondary road. So this target should be, I'll click here, this is alignment, so I click the left side and click this one and right click. So you can see this is set. Then so if you apply, you will see it is connected now, but it is only connected in terms of width. Now I have to set the elevation targets. So the elevation targets, we have to set the profile of this one. So I'll click here and it should be secondary road profile. So it should be secondary road profile, and I right click to confirm the selection. Then I will click OK. Now this is complete, right? So next I have to complete this part. So I'll click here, go to corridor, and I'll add this part and click OK. Now I select the corridor again, edit targets. This time I want to select this region, then I right click, enter. Then for the width target, it should be, this time we have this alignment here. So I'll select this one, and from the object selection cycling I can get this thing, enter. So it gets the width target. You can see now it gets the width target. Then this time we have to select the elevation targets. So this time we have to be careful because we don't have a profile views showing the elevations of this line. In that case we have to filter that alignment from here. I am going to uncheck all from here. Then it should be main road RHS. So the alignment name should be main road RHS. So not here, actually you have to go here. I have to select all from here and go to here. Then I am going to select main road RHS from here. So it will show you the profiles on that main road RHS. So we have to select this temporary corridor one from here. So still you are using the older versions of Civil 3D. You have to go with that options to get this done properly. So I'll click OK. Now everything completed in terms of the southwest curve return. So you can do it with yourself to get this part done correctly to create the southeast curve return. So in the next video we will see how to create the corridor surface for this intersection corridor. In this section, we are going to create the corridor surface for the intersection corridor. So to do that, I'll select my corridor, go to corridor properties from here, go to surfaces tab, click here to create the corridor. So my corridor surface name would be intersection corridor top, and I would add top codes as our data for the surface and overhang correction with the top links and add them as break lines, and finally add the intersection corridor top as the corridor extent as boundary, right? So then I will click OK here. So my corridor is now created. Corridor surface is now created. I'll click this corridor surface, then I go to corridor surface object viewer here, and I click this and see how my surface looks like. So if everything is correct, you will see a very accurate smooth surface. So we have small anomaly here, otherwise all of these are perfect. You can see it's very smoothly running corridor. So if your corridors are, or if your profiles are not matching with each other properly, it will not give a smooth corridor. For example, if your target mappings and matching profiles are not correct, you will not get this kind of smooth corridor surface. So if I press escape and let us say I forgot to set this elevation target here. So I go to here and let us say I forgot this elevation target on this southwest region. So I go to targets here. So elevation target, this is the secondary road profile. Let us say I forgot to set that one, right? So now I rebuild the corridor. So now still the corridor would be looking fine on the plan, but if you go to the corridor surface and go to object viewer, you will see this kind of behavior because your corridor is not properly connected with each other. There are elevation discrepancies, right? So that is how you will identify these things if there is a problem, especially from the corridor. I'll undo these parts. So now I am going to resolve the issue somewhere here. I will check once again the corridor surface. So it is coming somewhere here. So I'll press escape. So I'm now going to change the surface styles. So this EG surface is also there. So it's better to turn off the display of the EG surface. Otherwise it will cause us problems when we are editing the corridor surface. So now what I do is I set my window like this. Then I'll press my shift key, press and hold my shift key, then press my mouse wheel button, and click upwards, right? It will give kind of a 3D view of my corridor. Then for instead of 2D wireframe, I'll set it to conceptual, right? Set it to conceptual. So if you zoom now somewhere here, you can see there is kind of a error somewhere here. So this is in this color, but you can see there's some difference in here. So this is where we need to address. I think you can remember if I go to corridor here, surface here, and show you that, you can see this part is already shown in that view. So I press escape. So this is the part we have the problem. So I select the surface, go to edit surface, then click swap edge here. Sorry, it is not giving that option. So I go to delete line option. So I'm going to swap the edges here. So it says you must have triangles displayed for this operation. So I need to show the triangles in this surface. This is on border only stage. So I go to properties. So only border it is shown. I go to here. Then I will show the triangles as well. It should be on the plan. It should be on the plan and triangles, and click OK, and click OK again. So now it is shown here properly. So now I am going to use swap edges and click this edge and click here. Click here, both you have to click, and I think now it is very much done. You can see now it is done. So what we did was we were swapping the edges, right? Swapping the edges to get a more accurate corridor. So you have to do this for the both triangles in that location to get the more correct updated model. So after completing that one, you can go to top here and go to 2D wireframe here. So that is how you create the corridor surface and create it more accurately. Now we can turn off the triangles in the corridor surface, otherwise it will be very hard to view these things in this view. So I'll turn off the triangles, click OK. So now everything is done and we have updated the corridor surface. Next thing we are going to do is we are going to check the drainage issues on this corridor so that it won't have any drainage issues on my corridor surface or this intersection. In this section, we are going to check the drainage condition of this intersection, because if there is water collecting in this intersection area, especially in this area, since the vehicles are turning this way, it would be a problem for the vehicles because of the collection of water. So we have to make sure that water is not collecting or water is not ponding in this intersection location. So to check that one, we have several ways. So one method is turning on the slope arrows in your corridor surface. So you go to here, go to edit surface style, then go to display tab and go to slope arrows and click this one, then apply. It will show you so many arrows, it is very hard to check it from here. So go to watersheds here, no, analysis here, then go to slope arrows. So make sure this length is like 1 millimeter, 1 meter, so it will give you more smaller arrows here. So then click OK. So make sure that these arrows are turning away from this surface, or these arrows are going away. None of the arrows are staying on this inside the intersection area. You can see all the arrows going away, like this water is going away towards this area. This is also water is going away toward this area, right? That's it. That is one way. If any arrow is have a very smaller angle, or it is not going to drain away from the corridor, that should be a location to think of, right? So you have to make sure that it is not going to happen. The other way to look at that is you can click the corridor surface here, then put some water drops on top of the corridor, actually on the surface, and check whether all these water is going outside the surface. So I click this water drop and I'm accepting the default values. I click OK. So let us say I'm putting a water drop here. So you can see it is draining out. If I put a water drop here, sorry, it was snapped somewhere else. So if I put a water drop here, you can see it is going out. So in this way it is going out. So you can clearly see the water is going out from the intersection surface. So that is a good indication that your surface is created nicely. So I press escape. So in any case, if the water is collecting, so if this water drop stops somewhere here, that means water is collecting in that area. So if that happens, what you have to do is either you have to change the intersection profile in between here and in between here according to the location, or otherwise you have to change the main road or secondary road profile at the intersection location to get the correct drainage. So in this case you can see at the intersecting location our secondary road have a slope of 2.5 downward somewhere here. That means water is mostly draining off towards this. So if this drainage, if this line is very flatter like here, so if this angle is also flatter and if this line is also flatter, so that is an indication of water is not going to drain off so fast. So in that case you have to update the profile of this secondary road and the main road. So if the main road gradient, so the main road gradient at this intersection location somewhere here, so it is 0.51. so if this gradient is like 0.1 or something like that, so it will restrict water from draining off the surface due to the lesser slope. So in that case you have to increase the slope of the main road, or otherwise increase the slope of the secondary road, and also change the middle part of these curb return assemblies to get more desired profiles, desired corridors to drain water out from the corridor surface, or in otherwise drain water out from the intersection. So that would be a very good practice to do a very safety related design in terms of the intersection. So that is how to check the drainage issues in your intersection you have created. In this section, we are going to see how to create data or prepare data for issue for construction or IFC. So our ultimate goal is to issue this data to the construction purpose. So when you are considering the intersection area, this would be our intersection area. Other areas belongs to main road and the secondary road. So we will be only getting or preparing data related to the intersection area only in this section. So I have to filter the intersection area only from this corridor. So what I do is I will go to intersection corridor from the prospector tab, intersection corridor, right click properties. So this time I will turn off my main road and secondary road and click OK and rebuild the corridor. So you can see now my corridor is turned off. So when you are considering about the curb and return alignment and also the daylight area, they are general normal things. So especially when you are issuing the junction data, the most important thing is to issue this data inside this pavement. So we will only considering the issuing of data related to the payment at this section. So what I need is I need to remove these parts from the drawing. So when I am removing these parts, make sure you are doing this in a separate drawing or a copy of your original drawing, because we are removing parts of the corridors. If you remove the parts of your original model or original drawing, you will lose them. So because of that, you have to use a copy of the original drawing to do this work. So I am going to remove these parts now. So to do that, I go to my assembly. This is my assembly related to the curb return. So I will delete these assemblies, select all these assemblies on the left side, and I will delete them. So my corridor now gets up, should be updated because I have changed the assemblies. So I right click here and go to rebuild. So when you rebuild, just check the surface whether it is correct. I can see there is some issue in here because these uh, triangle so slope arrows are not behaving properly. So I go to the surface and go to the object viewer and see whether there is some problem. So you can see there is some kind of a problem here. So in that case, you have to go to the targets and recheck. So because the issue is in this area related to the secondary road, so you have to recheck the target. So I click here, go to edit targets and click this area and right click, enter. So you will see now my outside elevation target, it should be secondary road profile, so it is not selected. So I select that one here, click OK. Now you can see it is now properly connected with both sides of the corridor. Now you can see, again go to the profile surface and see whether it is okay. Now you can confirm now your corridor is okay. So this time what we do is we are going to issue the data for the construction in terms of uh, contours. We will be looking at few methods. So first one is we are looking it as contours. So to get the contours, first I will freeze this corridor to get a better view of the surface. So I'll freeze this corridor and I go to the intersection corridor surface, go to the surface properties. This time I will create a new surface from the copy of this current surface. So I would say this design or contours proposed contours over here, then 100 millimeter major and 20 millimeter minor. So our major contours will be at 100 millimeters, minor contours will be at 20 millimeters. So I go to the contours tab now. For the contour interval, make sure this is 0.024 20 millimeter and 1.14 major interval, right? So then I go to the display tab. So I make sure my major contours and minor contours are turned on in this case. So if you like, you can change the colors of these as well. So these are the colors right now, but if you like, you can change the colors as well. So I click OK. Now this is my stripe. So I click OK again, and we want to do some other change as well. I go to edit current selection. So we have slope arrows turned on. So I'm going to turn off the slope arrows. So I click OK and click OK again. So you can see now my contours are displaying. So you can see some kind of bit and bobs in this surface. So you can optimize the surface by clicking on the surface, edit surface, smooth surface from here, then go to output region, make it as surface, and grid X spacing, let us say 0.5 meters, and grid Y spacing, let us say 0.5 meters. So it will optimize the surface. We'll click OK and see how it gets like. So now you get a better contour output. So now this is okay. Now before getting this output, we need to label these contours. So I am only going to label the major contours. I am not going to label the minor contours. So I click on this surface, go to add labels, then go to add surface labels. So you will get this window, add labels. So I am going to add the labels for contour single. I am not going to add minor contour labels and user contour labels. I am only going to add the major contour labels. So I set this as propose major labels. Then I click add. Then I click this contour line. It gives a label, but you can see it is kind of a bigger label. So I press escape. I need to edit this style to get a smaller label. So I'll go to here, edit current selection. So on the layout tab, you can see this text height is 2.54. So I'll change this to 1.5 to get a smaller value, right? So you can see it is still higher value, but this time I will change the scale like 1:250. So now you will see more viewable text here. So again, now I am going to add the labels. I click add here. I go to here, add this other major contour, and go to here, add the other major contour, and here also, and here also, and here another one somewhere here. So I'm turning off my object snap at this moment, and another one here, another one here, and another one here. So in this another major contour here as well, right? So in this way we can get more control over the contours labeling. Otherwise you can use contour multiple also, but at that time you cannot get much control over the labeling. This time you can get a better control over the labeling if you go with this way. So now we have our contour labels done. So what you can do here at this moment is you can save this drawing as a new file, so naming this IFC contours or something like that. Later you can get a PDF of plot of this drawing, and maybe we can give these details to the site construction to create the surface and everything to get this detail, right? So that is how to use contours for the construction. You can give these contours to the construction teams, right? So I close this one at the moment. Next we will see how to do the same thing with points. So I am going to turn off this surface, no display. So this time, to get the points, what I do is first I'm doing some trick here. First I am clicking, I turn on my object snap, I am getting this point and I'll get this point. So this is my contour, sorry, this is my rectangle. I'm creating a rectangle, so make sure your these object snap are turned on center, endpoint and extension, so you can snap to the points very easily. So I get this rectangle here. So in this rectangle, in this area, we are going to create points. So what I do is I am going to offset this by 1 meter out, 1 meter out. Then I delete this one. Next, what I do is I am going to points, then surface on points on grid. This done. So now you have this toolbar here. So you can see it is a little bit out because of the visual issues, but you have to go to here and go to point creation, then prompt for elevations, it should be automatic, and prompt for descriptions, it's also automatic, right? That's it. Now it is asking for a surface. Now I press enter here. I'll select this surface, my corridor surface top, click OK. So it is asking the base point on my grid. So my base point would be this one, the rectangle I created. And it is asking the grid rotation. It will be 0. I press enter. Then it is asking for the grid spacing. I select at 1 meter spacing for X and Y 1 meter spacing and press enter. And it is asking to specify the upper right corner of my grid. So this is my upper right corner. I am snapping to the upper right corner and click here. So it shows the grid same as the rectangle we created earlier. So if you want to change this, if you are not satisfied with this grid, you can click yes and redefine it again. Otherwise click no here. So it will create points on this grid within the surface. So now you can see it has created points along 1 meter grids across this surface. So I press escape. So I delete this one as well. So if I delete this and turn on that surface again for border only, so you can see now these triangles are turned on. I will turn off the slope arrows. So you can see now there are points along a grid across this surface. So if you give these data to the site, they can locate these points on the site and create the intersection surface. So that is how to give the elevations to the surface in terms of points and in terms of contours. So still we haven't given these edge detail. So these edges are as alignment. So we need to get that detail to the site as well. So before doing that, you can save this drawing also as points so that we can give that to the site. So then what you can do is create this create setting out or the alignment details which we can give to the site or construction personnel. So to do that, we go to the toolbox tab, then report manager, expand this alignment. So you can use alignment curve or station curve, like some kind of option which is satisfied with you. So I'm going with alignment curve, right click, execute. So it is asking for the alignment we need to use. So I'm going to uncheck all first. So I don't want the main road, LHS, RHS. I know I need SE curve return, this one. So I click here, and I don't need secondary road. Secondary road LHS I don't need, and RHS also I don't need. I need SW curve return. So I will click this one, SW curve return. That's all I want, both SW and SE curve return. I click OK. So from here, make sure you are using an Excel workbook. It will give you the output as Excel workbook. If you want other types, you can get it from here, but I prefer this one, Excel, straight away. So you can override this existing one, or otherwise you can select whatever the name you want. So you can also select a location for this one as well. So I click save and I override this one. So after some time, it will extract this report and give you the Excel report for your viewing. So now you can see our Excel report is completed. It shows all these data, tangent data, directions and everything according to the tangents and curves and lanes, everything. So this can be set out on site for the SE curve return and SW curve return. So this data, if you go to site, they can set out on site using the available detail. Then we will see another way to get the details. So I close this one. I'm going to station and curve report this time. Right click, execute. This time also I'll be selecting the SE curve return and SW curve return. So click OK. This time I will give it as Civil Report 2 and hit the Excel. So this time we will getting another report giving the stationing data with northing and easting values, and also the curve data as well for SE curve return and for SW curve return. So you can give both these reports, or either one of these reports for the to the site or construction personnel to complete the construction work or setting out the construction work at the site. So this is how you get these details to issue for the site and complete the construction work for the intersection we have just modeled.